Okay, right here at the beginning of this video, I'm actually going to ask you to pause this video, and I want you to go ahead and use this as a warm-up, and I want you to try and solve this by factoring. What exactly does that mean? What I'm saying is I want you to factor this, set it equal to 0, and figure out what two values here would make this equation 0. So go ahead, take a couple minutes, pause the video, and see what you can do. Okay, hopefully what you figured out by now is that this is unfactorable, meaning that if I put x and x here, I need to be working with the factors of -9 to give me -2. Well, what are the factors of -9? It's either going to be -9 times 1 in either order. This could be -9 and 1 or 1 and -9. And then it's obviously -3 times 3. And in both of these cases, there is no way for me to multiply these numbers in such a way, or add these numbers in such a way that I get -2. And in fact, this quadratic is unfactorable. It's completely unfactorable. No matter how hard you try, you cannot factor it. And so what do? Do we just guess and check what numbers to plug in for x to give me 0? No, you don't. We actually use this other technique. Instead of solving by factoring to figure out what we need to plug in here to get this to 0, we use something called the quadratic formula. And hopefully this has a little bit more meaning to you now that you know what a quadratic is. That this is what we use to solve these unfactorable quadratics, because not all quadratics are factorable. Okay, so in the quadratic formula, the most common error I see is that students try to put variables into the quadratic formula. You can see here that there are lots of variables in here. There are a's, b's, and c's. But remember, in the standard form of a quadratic equation, it was ax squared plus bx plus c equals 0. Where we had these letters A, B, and C that stood for the numbers that are in front of each variable. And so whatever number is in front of the x squared, the squared term, is always A. So here, there's not one there, but there actually is one. We just don't write it. There's a 1, right? There's 1x squared. If there were more than 1x squared, it would be written 2, 3, 4. So there's a 1. So A here is 1. Okay, what is b? B is what's in front of the x term, and so clearly b is -2. And then c is the constant term. C is what stands out here by itself. C is -9. All right, so now we have our a, b, and c to plug into this quadratic formula. Okay, so let's do that, and we'll do this example together. So remember, we're solving for what x could be that will make this 0. So our answer should be x equals. That's why it's written like this. So x equals negative b. So b is -2. So -2 is just +2 plus or minus the square root of b squared. That's -2 squared minus 4 times a is 1, times c, which is -9. All of that over 2 times a. Well, what is a? A is 1. 2 times 1 is 2. Now, are we done? No, we have lots of stuff here. We need to simplify what's underneath this radical. So we're not going to worry about anything that's underneath the radical for a little bit. So we're only going to do the math underneath the radical. So here we have 2 plus or minus, that stays out in front, the square root of, and let's go ahead and do this math. -2 squared is -2 times -2, which is going to be +4. -4, so this is -4 times 1 times -9. So we can treat this 4 here as negative. -4 times 1 times -9 is +36. All of that is still over 2. So I'm going to move down here really quickly, and I'm going to continue right here. So now I still need to do some work here. So 2 plus or minus root 40. 4 plus 36 is 40. All of that over 2. Now you would say, am I done? No, you're not. Why? Because this radical right here can be simplified. I need to simplify this radical first. So I need to pick some factors of 40 that would give me a square number. Well, clearly 4 and 10 are factors of 40, and 4 is a square number. So I'm going to choose that one because when I do this, it will make my life easier. So I'm just going to first, before I come back here, what I'm going to do is I'm going to simplify root 40 first. So I'm going to write it out here to make it easy to see. Root 40 is the same as root 4 times 10. Okay, and I could rewrite that as root 4 times root 10. And that would simplify to root 4 is 2 times root 10. And 10 cannot be simplified. It's just 5 times 2. So this is root 40. 2 root 10 is root 40. So where it says root 40 right here, I can actually just plug in 2 root 10. So I'm going to try and do this right down here really small. 2 plus or minus 2 root 10 all over 2. Now, this is 2 answers. And you will always get as many answers for what x can be as the highest powered term. So here the highest power is 2, so I should get 2 answers. How is it 2 answers, you might be saying? Well, I have 2 plus 2 root 10 over 2 and 2 minus 2 root 10 over 2. So this is 2 answers, and we actually can simplify this a little bit further. Since this number, actually I'm going to do that in a different color. Since this number, and this number all have a shared factor, and that factor is 2, I can reduce this. So I can actually reduce this to 2 divided by 2 is 1. Again, 2 divided by 2 is 1 again, so that just becomes 1 root 10, which looks like that. And this is all over 1. If I simplify these, if I cross all these out and make them 1, then this would be over 1. But remember, anything divided by 1 is just itself, so our final answer here is 1, and I forgot the minus, 1 plus or minus root 10. Right? So sometimes when we use the quadratic formulas, our answers aren't so nice, neat, and clean. They're actually pretty complicated and messy. But this can be a very useful tool to help us figure out when a quadratic is not factored, what values for x would make a quadratic equal to 0. You have 2 more examples in your notes that I want you to take some time and do on your own. And I would always encourage you to go ahead and write out what A, B, and C are before you start. It'll make your life a whole lot easier.